Alright guys, so I wanted to start this video in a slightly different way, but it required me to measure, and I couldn't figure out how to get a ruler to pop up on my screen to show you all how to measure. So I decided I would skip that activity, and we're going to jump right into a mathematical modeling exercise. Now throughout this lesson, it's called the most famous ratio of all, we're going to be talking about the circumference, the diameter, and the radius of a circle. And it's important for you to understand what the circumference of a circle, what the diameter of a circle, and what the radius of a circle are. So, I would like to take a minute just really quickly to draw out two circles for you to show you the difference between the radius and the diameter. Okay, so firstly, there is a line that we can use to split a circle into two halves, and we call that line the diameter. So when a line stretches across the entire circle, we call that the diameter. When we have a line that only extends halfway across the circle, and I know that I'm really bad at drawing circles, so when we have a line from one side of the circle to the center, we call that the radius. So the radius is half of the diameter, or we could say that the diameter is twice as long as the radius. And so we find the diameter when we only have the radius by multiplying the radius by 2. So we represent it as d equals 2r. And that's how we find the diameter of a circle. Now, we're really going to be focusing on the circumference throughout this lesson. And the circumference is all the way around a circle. So we want to know, pretty much, the perimeter of a circle. So when we're looking at a rectangle, and we want to know the perimeter, or the entire length or width of the rectangle, we would say we want to know the perimeter. And so we have two lengths when we're looking at a rectangle, and we have two widths. And so we represent the perimeter of our rectangle as 2L plus 2W, meaning we're going to multiply the width by 2 because we have two widths, and we're going to multiply the length by 2 because we have two lengths. And then we're going to add the width and the length together, and that's going to give us the perimeter, or the outside measurement of the entire rectangle. And so we can do the same thing for a circle, but we call the perimeter of a circle the circumference. So in this mathematical modeling exercise, it tells us that the ratio of the circumference to its diameter is always the same for any circle. The value of this ratio, circumference divided by diameter, is called the number pi, and it's represented by the symbol pi. So we need to understand what pi is. And so since the circumference is a little greater than 3 times the diameter, meaning all the way around the circle is about 3 times as great as the length across the circle, pi is a number that is a little bit greater than 3. So we use the symbol pi, or this is our symbol for pi, to represent this special number. Pi is non-terminating, meaning it extends on forever. It is a decimal that extends on forever. It just keeps going. It is a non-repeating decimal, meaning that none of the numbers repeat again. They are continuously different numbers for the entire length of the number, which is non-terminating, meaning it does not end. And mathematicians use the symbol pi, or approximate representations, as more convenient ways to represent pi. So when we're talking about circles, we use the number pi, and pi is equal to about 3.14, and we can represent it in fraction form as 22 over 7. So the ratios of the circumference to the diameter and pi to 1 are equal. So what we're saying is that when we divide the circumference by the diameter, it is the same as dividing pi by 1. They are equal ratios. So the circumference of a circle can be represented as pi times the diameter. So we represent the circumference, meaning the entire way around the circle, as pi times the diameter. And remember, the diameter is the distance all the way across the circle. So we're going to understand how we can use this information, meaning how we can use the information of, well, if we have the radius of a circle, we can find the diameter to find the circumference of the circle. So that's what we're going to be looking at today. Primarily, we're going to be looking at finding the circumference of a circle. And we're going to end today by talking about how we can find the circumference of an arc. So half of a circle instead of an entire circle. So we're going to move on now, and we're going to look at the first example. And for part A, it says the following circles are not drawn to scale, meaning that is obviously not 91 feet. Find the circumference of each circle. Now they're asking us to use 22/7 as an approximation for pi. Now remember, we said that we can represent pi in three ways. We can represent pi as a symbol, just like this, and that symbol equals 3.14. And remember, that decimal just keeps going. So it's actually 3.1415, and then the decimal just keeps on going, and it doesn't repeat. It's non-terminating, it doesn't end, and it doesn't repeat, meaning we're not going to see the same numbers over and over and over again. In this lesson, we talk about how we also represent this decimal as a fraction of 22/7. Now, anywhere else in math, you're not going to see pi represented as 22/7, so don't get too comfortable with that fraction. We are going to use it for this lesson because that's what they ask us to do, but that's not the way that we represent pi anywhere else in math. All right, so it asks us to find the circumference of each circle. So remember, the circumference of a circle is equal to pi times the diameter. So what we're saying in this problem is that we're going to find the circumference of the circle by multiplying the fraction 22/7 by the diameter. We're replacing that 22/7, we're replacing that pi symbol with 22/7. That's the number that we're using. So for each of these circles, we're given either the diameter or the radius, and we need to use that information to find the circumference. So for example, in this first circle, since we have the length all the way across the circle, we say that the diameter is 21 centimeters. Now, if we wanted to know what the radius of the circle is, meaning from this point right here to the center of the circle, we would just divide 21 by 2, because it is half of the diameter. But we're not interested in the radius right now. We want to know what the circumference is, or the entire way around that circle. So we're going to find that by saying the circumference is equal to 22/7. We're using that fraction in this problem. And we're going to multiply it by the diameter. And they told us that the diameter is 21. So we're going to multiply straight across to get our answer. So when I multiply 22 by 21, because we're multiplying straight across, I get 462/7. And when I divide 462 by 7, I get a perfect number of 66. And in all of these problems, when I'm finding the circumference, I'm always going to take my units with me. So my units here are centimeters. So the circumference of my circle is 66 centimeters. Let's use this same practice to find the diameter of our next circle. So our next circle, the circumference of our next circle. So for the next circle, the diameter is 91 feet. So we're going to use that information to find the circumference. So remember that we're going to multiply, in this case, 22/7 by the diameter, which is 91/1. And when I multiply straight across, when I multiply 22 by 91, I get 2002/7. And when I divide 2002 by 7, I get that my circumference is 286, and I'm going to take with me those units. So 286 feet is my circumference, meaning the entire way around my circle is 286 feet. Now, this next circle that we're given is a little bit different than the last two that we just saw. And here's why. Because they tell us that the radius this time, so I'm going to draw a couple more arrows here so we can see this. Our radius is equal to 35 halves. So 35 over 2 meters is our radius. But we're not interested in using our radius. We want the diameter, which is perfectly fine. We just need to multiply this radius by 2. So we're going to use 35 over 2, and we're going to multiply that by 2 over 1. And when I multiply 35 by 2, I get 70. And I'm not going to reduce this fraction. I'm going to keep it as 70 over 2. And that's because I just doubled it, and I don't want to reduce it. If I reduced it, it'd take me back to 35. So, because 70 divided by 2 is 35. But I don't want that. So I'm going to keep it as 70 over 2. All right. So now 70 over 2 is my diameter, or my diameter is 35 meters. So I'm going to keep it as 70 over 2. And remember that we're using the fraction 22 over 7. So I'm going to multiply that by 70 over 2. And so I'm going to multiply straight across. So 22 times 70 is 1,540 over 7 times 2 is 14. So I come to the understanding that when I divide 1,540 by 14, that the circumference of my circle is 110 meters, meaning the entire way around my circle is 110 meters. So that's how we use the information, either the diameter or the radius, to find the circumference of a circle. Now they are going to tell us to either use 22 over 7 or 3.14 or the symbol pi on our calculators. So we're going to look at part B for a slightly different representation of us finding the circumference of a circle, even though we can't actually see that circle. So they say the radius of a paper plate is 11.7 centimeters. And if we were to draw that out, so let's pretend that this is our paper plate. So what we're saying is from this point to the center of our circle, that is 11.7 centimeters. That's what we know. Find the circumference to the nearest tenth. And we're using 3.14 as an approximation for pi. All right. So we know that we're going to find the circumference of our circle by multiplying pi times d, or the diameter. So in this case, we're saying c equals 3.14 times the diameter. Now, in this case, they gave us the radius. Remember that we can find the diameter of a circle by multiplying the radius by 2. So we're going to find the diameter of our circle by multiplying our radius, which is 11.7, by 2. And we come to the conclusion that our diameter is 23.4 centimeters. 23.4 centimeters. So we're going to find the entire distance around our circle by multiplying 23.4 by 3.14, because we're representing pi as 3.14. So we're going to multiply 3.14 by 23.4 centimeters. And when we do that, we find that the circumference of our circle is 73.476. But remember, they asked us to round to the nearest tenth. So remember, this is our tenths place. This is our hundredths place. This is our, no, I'm sorry. That's not right. Yeah, that's right. This is our thousandths place. So we are right here at our tenths place. That's where we want to round to. We want just one decimal. So because in our hundredths place we have a 7, we're going to round our 4 up. So our circumference, we're going to represent it as 73.5 centimeters. That is the circumference of our circle. That is our final answer. So we just need the information of how to determine the diameter from the radius and then how to find the circumference from multiplying the diameter by pi. So we're going to take a look at a couple problems similar to this one in the next slide. So let's take a look at that right now. All right, so we are asking ourselves in this problem for part C, it's saying again that the radius of a paper plate is 11.7 centimeters. So again, we have our paper plate here. Our radius is halfway across the circle. So our radius is 11.7 centimeters. That's the same information as last time. But this time it's asking us to find the circumference to the nearest hundredth, and it's also asking us to use the pi button on our calculator as an approximation for pi. Now, remember that pi is a decimal that does not end, and it's also a decimal that does not repeat. So when we approximate for pi, when we say that pi is 22 over 7 or 3.14, we are really rounding that decimal. When we use the calculator does not round the decimal, so it gives us a more approximate, or I'm sorry, a closer answer to the correct answer. Whereas when we're rounding or not using the full decimal in terms of pi, we're really just approximating our answer. We're not as close to the real answer as we could be. So we're going to use on our calculators, and I wish I could show you this, the pi button so that we can get as close to the actual answer, meaning the circumference of this paper plate, as we possibly can. So remember, we're going to find the circumference by multiplying pi by the diameter. And firstly, we need to find that diameter. So remember, we can find the diameter of a circle by multiplying the radius by 2. So we're going to find the diameter of this paper plate by multiplying 2 by 11.7. And when we do that, so we have 2 times 11.7, again, that equals 23.4. So our diameter is 23.4 centimeters. All right, so we're going to find the circumference of this paper plate by multiplying 23.4 by pi, and I just rearranged that, and that's perfectly fine. So when I type that into my calculator, 23.4 times the pi button, I get that my circumference is 73.513. Now they asked us to round it to the nearest hundredth, so I need to stop here at this 1. And since that 3 is less than 5, I'm not going to round up. So the circumference of my circle is, 73.51 centimeters. And that's my final answer. So that was me using the pi button. So if I go back really quickly, when we rounded and our plate was 11.7, or it had a radius of 11.7, when we rounded and said that pi was equal to 3.14, we came up with our circumference being 73.5. When we did not round, we came pretty close, but not as close. Because remember, back here it was actually 73.476. Here it's 73.513. So there's a little bit of a difference in terms of that decimal. So this is actually a closer answer than the answer that we had previously. So here is the circumference of our paper plate. All right, so we're going to look now at part D. And part D is it's going to be a little bit confusing, but it makes sense in the end. So a circle has a radius r centimeters and circumference c centimeters. Write a formula that expresses the value of c in terms of radius and pi. So remember, we have a couple of things going on here. Firstly, we know that the circumference is equal to pi times the diameter. And we know that the diameter is equal to 2 times the radius. So what we're saying is, if we are given the radius and we need to find the circumference, we can represent this formula in terms of pi and the radius by saying the circumference is equal to 2 pi r, because we need to multiply 2 by our radius to get the diameter, and we're still going to keep our r. So we can represent the circumference as 2 pi r. For example, if we're given the radius, instead of finding the diameter before we find the circumference, we can just go ahead and find the circumference by multiplying 2 by pi by the radius. So we're actually going to look at an example of that in just a moment. But we're going to kind of end this lesson with part E. And part E says the figure below is in the shape of a semicircle. A semicircle is an arc that is half of a circle. So imagine that if I was going to continue this circle, I would just have the other half of that circle there. But since I don't, I can't use that information. So we need an equation that will allow us to find the perimeter of the shape, or the circumference of this half of our circle. So we have an equation in order to do that. We use the equation the perimeter equals the diameter plus half pi times the diameter. Because really, we want half of the circumference. And remember that we would find the circumference by multiplying pi times the diameter. So we only want half of the circumference because this is only half of a circle. So we're going to use this equation to represent how we find the perimeter of a half circle. So keep this in mind for your homework today. So we have the information that the diameter of this half circle is 8. So we're going to find the perimeter, and we're using 3.14 for pi. So we're going to find the perimeter of this half circle by the diameter, so it's 8, plus 1/2 multiplied by, we're going to use 3.14, multiplied by the diameter again, which is 8 meters. So I'm going to go ahead and plug into my calculator 3.14 times 8, which gives me 25.12, and I'm going to multiply that by 1/2. And so I get P equals 8 plus 12.56. So when I add those together, I determine that the perimeter, or the circumference of my half circle, is 20.56 meters. That is the circumference of my half circle. So you are going to find a problem like this in your homework, and so you will need this equation here in order to complete that problem. So make sure that you are writing that equation down so that you can use it for your homework. So I'm going to flip now to the next slide, which is actually a review for you. So I'm not actually going to go through all of these vocabulary words because we already have. You all know what a circle is. And the radius of a circle is half of the circle across. And then the diameter of a circle is the length all the way across the circle. So those are our vocabulary words that we already went over today. And then the circumference is all the way around the circle, the distance around the circle. And we find the circumference using the number pi. And we represent pi, or we approximate pi, as 3.14 or 22/7. And then we can also find the perimeter of a semicircle. So a semicircle is half of a circle. And remember that we find the perimeter of a semicircle by adding the diameter to 1/2 pi multiplied by the diameter. So just don't forget that equation. All right, there's one more thing that I want to go through with you guys, and it's not something that you need to know for your homework, but I think it's important for you to understand for future lessons. So we have here something that's a little bit different from anything that you've seen so far. So it says, Brianna's parents built a swimming pool in the backyard. Brianna says that the distance around the pool is 120 feet. Number 1 says, is she correct? Explain why or why not. All right, so when we're doing this, we see that we have a half circle on this end, and we also have a rectangle. So we find the perimeter of a rectangle, remember, by 2 multiplied by the length, plus 2 multiplied by the width. But notice that we only have one width. We don't actually have 2 widths because this is not technically a side. So we actually only have one width. So we're going to find the perimeter of this pool. So we find the perimeter of the rectangle by adding up those sides. So we have 20 feet plus 40 feet, which is one side, and we do have another side, so plus 40 feet again. So we come to the conclusion that the perimeter of that rectangle is 100 feet. Now we have to determine the perimeter of that half circle. Now notice that the length right here across this half circle is the same as this length down here, so we know that it's 20 feet. However, we don't really have a diameter across there because it's not really a side. So even though we represent the perimeter of an arc as the diameter plus 1/2 pi times the diameter, we're not really going to represent the perimeter in this case as that. We're simply going to remove that diameter because we don't really have one. So we find the perimeter of this half circle, or this modified half circle, by saying 1/2 multiplied by 3.14, we're just going to use 3.14 here, multiplied by that diameter, which we're saying is 20 feet. So when we calculate that all out, we end up with, let's see, 3.14 times 20 times 1/2 gives us 31.4. So now we're going to add those two perimeters together. So 100 plus 31.4. So that means that the perimeter of this pool is actually 131.4 feet. So Brianna was incorrect. No, she was incorrect. Let's look at the second problem here. It says, explain how Brianna would determine the distance around the pool so that her parents would know how many feet of stone to buy for the edging around the pool. So we would first need to find the perimeter, of rectangle. Okay, that was our first step. Then we need to find the perimeter of arc and then add those perimeters together. That is how we are going to find the perimeter of that pool. So I just wanted to give you guys a really nice example of how we could find the perimeter of something that is the combination of an arc and a rectangle. So you guys are not going to see this type of problem in your problem set or your exit ticket. This was actually the original exit ticket and I didn't like it, so I changed it. So you guys are going to find your exit ticket and problem set on GoFormative. Please find the links on Google Classroom and please make sure you complete those so that I can mark your attendance for today. You guys have a wonderful day. Email me or text me with any questions. Thank you.